Welcome to Walkabout the Galaxy, the funny astronomy podcast, where the science is universal, the opinions are personal, and the hosts are the most. We are strange, charming down the astroquarks, also known as Josh Caldwell,
Addie Dove,
and Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. Top quark Jim Cooney apparently has something called a real job.
What? Suspicious.
Real job.
Suspicious.
Understand.
I did a slight delay in my intro in honor of him.
Oh, I didn't catch that.
That was beautiful.
Yes, thank
I
you
was
for
wondering.
that. Yeah. And he's unable to join us for this episode. Follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, where the facts aren't checked and stories, like our collective memory, only last 24 hours. But they can be liked, so like away and tell your friends to listen to the best podcast and also check out Walkabout the Galaxy. Catch our videos on YouTube. Where did I mention I had an actual honest-to-goodness interaction with one of the band members for Rolling Courts?
You mentioned it to us.
Okay.
Do you know which band member?
I do, of course. The bassist, Aram.
Aram?
Yeah, Aram.
Okay.
Kim Aram. I can write it out in Hangul for you if you like.
Yes, please.
But I can't pronounce it very well, probably.
Oh, okay.
We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. Our stumper today is another forecasting stumper, although I do agree, Addie, that we should get back to well, that was a trivia thing.
Trivia.
Which of these is real?
Yes.
Yeah.
I always
We'd have
enjoy
like,
those.
this may be before Audrey's time, but some of our trivias would be like, I'm going to give you choices A through L, and 4 of them are
my
real.
God.
Is that kind of...
I don't remember that, but that
Yeah.
also doesn't mean that
I think
wasn't
these were
around for
before
them.
your time.
Okay.
Yeah. The stumper today is forecasting. Last time I think we asked, do you think people will go to Mars and come back
Right.
in your lifetime? And then an estimate for when you might see that happen. 3 out of 4 astroquarks surveyed said yes.
Wow.
Such a downer.
With a time range of 20 to 25 years only, which is pretty optimistic for the pessimistic trio of the
I know.
quartet.
Yeah.
And Miss Optimist over there was like, nah.
Just flipping everything on its head.
Yeah. So let's take the majority's opinion.
Okay.
People are going to go there in 20, 25 years. In the meantime, NASA, for a long time, has been working on a sample return
Oh, yeah.
project that is kind of underway, right? The Perseverance rover is on Mars. It's been filling up little test tubes with Mars samples and plopping them out on the surface and keeping some safely in its belly for potential future retrieval
Yeah.
by some future as yet unnamed, unfunded, and only partially designed mission. Cool. Right?
Yeah, totally.
So do you think we will have done a robotic Mars sample return mission before a human goes to Mars?
Oh.
And the corollary, obviously, is then, should we even be bothering talking about doing a Mars sample return
Just
mission?
have them go scoop it up.
Some person is going to, if a person goes to Mars, I guarantee you when they come home, they're going to have at least a baggie full of Mars rocks.
Yeah. I mean, that's one of the plans for like long-term lunar surface exploration, right? Is we send a rover that goes and collects stuff from a really large area and then plops it back down right near the Artemis landing site.
And then they just go and
And
pick
then
it
the
up.
Artemis astronauts bring it back with them.
Right.
That's the Endurance A concept.
Endurance A.
Endurance A is a long duration rover, and there's like an A and B mission scenario, and the A scenario is when they plop it for humans. The B scenario, I think, is one where they plop it for
For
an automated sample return.
Would the
Okay.
humans do other stuff?
Yeah, it's
Oh,
a- it's a
No, the
standard
humans would
Artemis
do nothing
mission.
else. The humans would land on the moon. They would
Pick
step
up the bag of
outside,
rocks.
pick up the bag, and come back
With
inside. They
their
go, I got the
satchels.
bag.
Yeah.
There's
And
going to
then
be a
take
picture
off.
of it on their doorstep from their home delivery driver.
Right. They would spend a
Wow.
total of like 9 minutes on the moon
Space
to pick
travel
up the
is
bag.
fun.
It is. No, yeah. I mean, the general idea is like it's a standard Artemis mission where you explore like your local area, but this would have
it
then
would go
samples
further.
from like kilometers away.
Ooh.
Right.
Yeah.
I like
Yeah.
that.
So what was the question?
The question is, do you think,
Yes.
really?
Yes.
Or do you just saying that and you don't remember
do
the question?
I also think
Okay.
Therefore-
let me ask you another question.
Damn.
Will we bring a sample from Mars robotically before a human goes to Mars?
Yes.
Okay.
Yeah, I mean, just based on my answer last week. I don't think we're going to Mars
Right. Okay.
anytime soon as people.
Okay.
But I think there's still momentum for the sample return. I think it's definitely died down a bit, but
I'm gonna
I think
have.
there's a little momentum.
I have the contrary opinion on this one. This episode. So the last mission concept that we saw for the Mars sample return involved so many crazily expensive
Yeah.
Yeah.
launches
Yeah.
to do this.
And a lot of
And a lot of it
European
was cooperative with the European Space Agency. And I'm just like, international cooperation on big expensive things that are not essential for health or defense or things like that, I think are probably not going to be moving much these days.
But we want to go to
pushes
Mars.
stuff- that pushes
Maybe
stuff
we will go to
down.
Mars. Yeah. Okay.
So,
Cool.
all right, I've
Great.
got the. Today we'll talk about whatever it is that Audrey's going to talk to us about,
And some other stuff.
and some stuff that Addie is going to talk to us about,
so specific.
and much more.
Wow.
You're going to talk too?
On this April Fool's Day.
That is a lot of
Episode.
stuff.
So much stuff.
Right. But first, this episode of Walkabout the Galaxy is brought to you by HST. For an out-of-this-world pick-me-up to start your day, have a cup of HST. Delicious, hot, and cold HST will have you seeing the universe more clearly than ever before. Since its debut in 1990, HST has been lighting up the days of the curious. Clear the morning groggies from your eyes and see things sharper, closer, brighter, and be inspired with HST. With decaffeinated options available, HST will work for you 24 hours a day. HST doesn't sleep, so you can make the most of your day. HST. Nature is our factory.
Hershey's chocolate.
I like
Folgers.
Remember, it's HST.
that. Celestial Seasonings.
It's a better guess than Audrey's two lame
It's
guesses.
not Celestial Seasonings.
Twinnings.
Ooh,
Also
nice.
a good guess, Lipton, as it happens.
Oh,
I guess drinks. It wasn't like that far off.
true.
Yeah, okay.
Are we going to spill the tea here on the pod today?
So much tea is going to be spilt.
I know.
Does that mean something
It does.
different than what I think it means?
It means
I don't
gossip.
know what you think it means.
Oh, okay. Sure. Do you have some?
I mean, I got gossip about some launches.
Yeah, let's start with
and
launch
People
gossip.
launches.
Some people launches.
We're going to rename the Space News segment Launch Gossip.
Launch gossip.
What about launch tea?
Launch tea.
I
like it.
heard.
T minus. Oh, I like.
Oh,
we can
man.
play on this. We can play on this.
Now
All
I'm
right,
gonna
we're
like
gonna
remember
workshop
this stuff.
this. Yeah.
If it's in
okay.
the gossipy frame, I'm gonna like be
We've
more
had
invested.
several beverages have sponsored the show from before your time, Audrey. For example, there was the famous Blue Or Gin.
Oh, cute.
Yeah, thank you.
Several beverages used to help facilitate the show in the early days of the show as well. So
So what's the launch gossip?
Mostly it's
I
coffee
heard,
these days.
tell me if this is true or not, but I heard some people took off into space last night.
I heard the same thing.
true. Did you actually hear it? Because it was from Florida.
I did not hear it.
I forgot to go outside.
Yeah.
I also forgot.
I actually wish I had gone outside. I didn't forget. I just was doing other things when it because it slipped a little bit from the initial. And anyway, but
So this is-
it would have been an interesting one to see.
Can
So this
you
is-
explain to me the name / acronym or whatever of this
Oh yes,
mission?
I can.
What is it?
It's
Flirt?
Fram 2 or
Fram
something.
2 mission.
I missed Fram 1.
There is no Fram 1.
Okay.
So Fram.
Is it like Fram squared?
So this is
Okay.
This is a mission that launched last night from the coast of Florida. It's a SpaceX Crew Dragon Resilience launch. And this is the Fram 2 mission, which I don't remember putting into my consciousness before a week ago that it was going to happen. But apparently it was announced in mid 2024, which was so long ago now. And it was-
Right.
and sort of
Many things have happened.
August 24, it was announced, and it was maybe going to go.
That coincides about with when I became obsessed with rolling quartz, which would explain why I paid
Convenient.
no attention
You haven't
to
had room in your brain for
for
this.
Fram 2.
Yeah.
Right.
So Fram it's a Norwegian. So this is a really cool mission in that it's it's the first polar human crewed mission.
That is correct.
So it's actually going over the poles, which is why it would have been really interesting to see because usually polar missions don't launch from Florida. Polar
Right.
missions usually launch from California because of
Vandenberg.
dynamics, orbital dynamics stuff. So they had to launch going south and avoid all of the stuff south of them in Florida because you're not supposed to launch over land, over people. And so anyway, it would have been a really interesting one to see. Fram comes from a Norwegian word for the poles, I think.
Okay.
Fram just means pole?
No, I looked it up just a second. Let me
So it's
find
not
it
an
again.
acronym, even though they spell it with all
It's-
caps.
It's not spelled with all caps. It's
It is.
FRAM,
Well, on that
capital
thing-
F.
Okay. The thing you were just showing me was in all caps.
No,
Yeah, that previous website.
no.
April Fools. All lowercase.
Oh, in the that thing up there, but down here in the words, it's not.
Yeah, but up there.
Yeah, sometimes
Okay.
it's all caps and sometimes it's
we
not.
all can
so
read.
it's not an acronym. And why is there a 2?
Because it's another one of these things where it's like all the Shift 4 from Jared Isaacman is because like his software thing was like Shift 4, and so his missions were like Inspiration 4 and stuff like that. Fram 2 is another like blockchain guy who had F2 Pool and
whatever.
Stakefish, which are
Okay.
among the largest Bitcoin mining
I've
pools
lost
and
interest.
Ethereum staking providers. So the mission commander and probably the guy who funded the mission is a Bitcoin rich man.
Okay.
And so he
Who
who was very interested.
Did not lose his Bitcoin password.
No, I
Like
guess
these
not.
people that
Yeah.
Didn't somebody buy a landfill? Did you hear about this guy?
No.
His Bitcoin, whatever you have to have for your
Mm-hmm.
Bitcoin, was like on some drive, USB or hard drive or something, and it got his girlfriend or somebody threw it out in the garbage, and it went to a landfill. So he bought the landfill.
No. Did he find it?
I don't know. The latest I heard was
Where's the
that he bought
update
the
on that?
landfill so that he can go find.
That's amazing.
So the interesting thing about this, though, is not the capitalization or the spelling, but that
It's named
going over the
after
pole.
Fram is named after a record-breaking Norwegian ship from the early 20th century that sailed to the polar regions in the late 18, early 19.
Oh, fun.
Okay, well then this could be Fram 2 then.
That's true. It could be.
This
Yeah.
the second one. All right. So a polar orbit. Our trivia actually will be
Things
connected
about
to the
poles.
inclination of orbits.
I'm inclined to be excited about that.
All right.
So yeah, I mean, it's another private astronaut mission. So they paid for this and said like we want to do a polar orbit, and it's kind of cool. So like the mission commander is Chung Wong, who is rich dude who wanted to go see the poles. I think he's been to the poles on Earth.
Oh,
And the mission specialist is like a well-known
and
polar explorer. He's a professional polar adventurer and guide.
none of these people has been to space before.
Correct,
Right.
yeah.
Yeah.
How many?
Eric Phillips is
Four
a
folks.
professional polar adventurer and guide, and he's also the medical officer. So he's been to the poles like, I don't know, a lot of times. And
Do
so he's
they-
excited to see them from orbit.
Do they talk about radiation hazards for these folks? How long is this mission? Because
It's like a 5-day mission.
in a polar orbit, even at a low altitude, you're not protected by the Earth's magnetosphere.
Correct. Also, you might be going through
least
interesting,
for
really
parts of
interesting magnetic regions like the South Atlantic anomaly and other things. So they have a lot of science mission. They have several science experiments on board. Their mission is 3 to 5 days,
Okay.
and they're going to observe Earth's polar wilderness. But they
The
also
polar wilderness
Yeah, I
in
didn't love
space.
that phrasing.
Yeah.
But so they're looking at. They have an X-ray device on board, so they're going to do X-ray imaging on orbit of humans and maybe of. I can imagine it just being one of those like little dental X-ray things that are
Wait
like
a minute.
handheld
What?
now.
What?
Yeah.
Wait a minute. Are they emitting X-rays and taking X-ray pictures of their
Yes.
teeth, or they have an X-ray telescope that
No.
will be detecting?
Internal
Oh.
Why?
to study medical imaging on orbit.
Okay. Doesn't really have anything to do with being on a polar orbit.
No,
Okay.
they just have a bunch of experiments also.
Okay.
They have a bunch of experiments to do in space.
Are they doing a spacewalk as well?
No, this one does not involve a spacewalk. They are going to observe Steve's
Oh yeah, nice. One of Addie's favorite
strong
things.
thermal emission velocity enhancements. And they've like put out a public
Steves
call
are
to
these like lightning-like things high up in the atmosphere.
or, like high atmospheric phenomena. They've put out a call to do like ground-based observations this week from folks and have folks submit aurora observations so they can do like ground and
Okay,
orbit kind
nice.
of things,
Yeah.
which could be fun.
Well, they should definitely get some interesting views of aurora. And wasn't there recently a large coronal mass ejection?
I I think so. I don't think it's super active right this second. Oh, let me look at spaceweather.com.
Have there been any like updates? Because it launched.
Launched 12 hours ago, roughly. Yeah. Oh, maybe a little bit more. But in any event, yeah, they're well. I mean, they have.
Aside from like looks good.
They should be on their orbit, their polar orbit, and orbiting roughly every hour and a half. So they've orbited multiple times, and yeah.
48 minutes ago, there's a picture. SpaceX shares stunning polar views from its historic Fram 2 mission, but it's taking a minute to load. So just
Do you have other tea to spill
about orbits and launches and stuff?
Yeah.
No.
Okay. Well.
Okay. So Blue Origin did post this week about how they wrapped up their anomaly investigation from their first orbital launch. So Blue Origin launched its New Glenn vehicle some amount of time ago. From Florida, and the orbital part went well, but they were trying to return the booster to the first stage to a ship, and it didn't work. So their anomaly investigation was, the engines didn't light like
properly,
they were supposed to.
Right.
So we're working on that and everything, but all the debris fell where it was supposed to fall, and so they're working toward another flight soon.
Right. So presumably, hopefully, perhaps, maybe in the first half of 2025 still.
Yes.
So in the next 2 or 3 months.
In the next few months, hopefully.
Yeah.
We'll see.
Where they will try again to land the booster.
Yeah.
Or ship the booster.
Okay.
Yeah.
And I kind of want to give you the trivia question now, since we've been talking about inclination. So just as a reminder and then we'll talk about our sciencey stuff.
Okay. We do have an observatory, a quick observatory.
Oh, let's do that.
Oh, first, really quickly, let's
do something else.
There are about 8 sunspots right now, and there is there's a crackling M-class solar flare going on.
Crackling?
Crackling M-class solar flare.
Is that an official designation?
4048 is growing and crackling with M-class solar flares.
What does crackly mean in this context?
I think
now I get it.
It means it's extra spicy. So it would be an interesting time to be on a polar orbit, but I would be a little bit concerned about radiation. And I'm sure that's at least one reason why they're not doing any spacewalks.
I'm also curious if it affects comms. But they have some optical comms and stuff, and maybe they're doing some Starlink stuff now. So
be okay.
They're probably okay.
Yeah.
It's pretty red at the poles right now. In terms of
activity. Yeah.
Hmm.
Your observatory updates?
Mm-hmm.
Yeah.
Going to the observatory.
I think we're a little rusty on our rust noises.
I know. That wasn't very
good.
That was very bad.
I would give us a C-.
Well, listeners, send us your rusty observatory opening noises.
Right.
So just, quickly, some JWST images were recently published. I know. Of Neptune.
I wonder if JWST would sponsor the podcast.
That'd be cool.
Yeah.
I'm going to ask.
New pictures of Neptune from JWST?
Of Neptune, and in particular looking at the auroras. It's apparently weird on Neptune because the magnetic field poles are offset,
Uranus
pretty
and Neptune
considerably.
have wonky magnetic fields.
That's my favorite thing about Uranus.
Well, it looks like the aurora are in
the equator.
Basically on the equator.
Right.
Plus or minus maybe I don't know, 20.
They're like 30 or something, yeah?
Yeah, 20 or 30 degrees. But it looks really cool. And it's the first time, I guess, that the ionosphere has been imaged on Neptune because it's so wonky and because it's so far away. The energetic particles aren't as energetic.
It's weird to me to think about imaging aurora with an infrared telescope.
I know.
Yeah.
Yeah, because JW is infrared.
Right.
Yeah, it's
we
the near
associate aurora
infrared.
emissions typically with ultraviolet.
With visible and ultraviolet. Yeah.
Right.
Yeah.
Higher energy. So these are some vibrational or rotational
it has
emissions?
something to do with H3.
Okay.
But that's all I know.
Okay.
Something to do with it.
Okay. Thanks for that.
No problem.
Thanks for that tea.
Made possible by near spec.
Yeah, it's definitely in the near infrared.
Yeah. Charge upper atmosphere, emissions of trihydrogen cation.
H3 plus.
Because H3 plus plays a crucial role in planetary auroras. Okay, yeah, that's not helpful. But also, they got a temperature reading of Neptune.
Cold.
which hasn't been done since, but it hasn't been done since August 1989, Voyager 2 flyby.
Yeah.
Good old friend Voyager 2. And the upper atmosphere has cooled by several hundreds of degrees in that time.
Wait a minute. What?
The temperature was just over half of that measured in 1989.
Oh, interesting.
Because of what season it's in, I guess.
Yeah.
I guess it must be
That's
in winter.
weird, though.
What season is it in?
Well, I mean, on the hemisphere that we're seeing, we're by the sun, so we're seeing the summer.
So wouldn't we see?
So the upper atmosphere, just for context there, Neptune's, of course, very far from the sun,
Yes,
very cold.
very far. Very, very cold.
But the upper atmospheres of all of the planets that have atmospheres can be very hot, but there's like not much energy there. That's one of the things we talk about in intro physics, is to sort of make a distinction between energy and temperature.
Yeah.
Because temperature tells you how much energy does each atom or molecule
How
have.
fast is it moving around?
Yeah, but if there aren't very many of them, there's not much stuff there.
My toddler is a very high temperature.
She's a high temperature atom, a high temperature particle. So the upper parts of the atmosphere are absorbing the high energy photons from the sun, and so those individual atoms, they're very hot. But there's you're kind of not really in the planet there. You're in a very upper, you're in the thermosphere.
And we don't see a lot of aurora
hotosphere,
activity, and
as
that
it's
might be
known.
tied to the fact that it's cooler there. Is like there's not a lot of higher energy stuff happening. Yeah, I don't know. I need to. There wasn't like an article about this because it's just like the stuff just came out, so there hasn't been like an article about it yet to talk about. Just a press release.
I mean, the upper atmosphere is heated by the sun, so I don't really understand why there would be such a big change.
I'll keep doing some research. Just
Okay.
a second.
All right. Well, let me give you your inclination-related trivia, unless you have another observatory update.
There
you wanted
was
to
no. I'm
give.
just kidding. There isn't anything.
Okay. That was pretty funny, though.
Wasn't it? April Fools.
Since we talked about inclination, just as a reminder, when we're talking about the inclination of an orbit, if you think about an orbit, we'll just consider circular orbits for simplicity.
Okay, great. I love a non-eccentric.
Oh, how dare you?
Zero eccentricity.
We'll consider a circular orbit.
Okay.
And so if you rotate that circle, you're changing the inclination of that orbit relative to some reference plane. And for orbits around the Earth, like for the Fram 2 mission, the reference plane is the Earth's equator.
That would be 0 degrees inclination.
Exactly.
So the Fram is somewhere around a 90-degree inclination.
Exactly.
I don't actually know if it's exactly 90 or not.
I don't either,
Probably
but
not.
what I found online listed it as 90, but I imagine that was a predictive
Yeah.
or notional number.
Cool.
So your trivia question has to do with the inclination of other missions that have had people. As we have just said, the Fram 2 is the first one with people to be in a polar orbit or a 90-degree inclination. Prior to that, what was the highest inclination human spaceflight? And I'd like to know, like, you can be as specific as you want, but you can have the program, like was it Space Shuttle? Was it Gemini? Whatever. The year and the actual, what was the numerical value of the inclination for that previous record-setting highest inclination
Is it an orbital
orbit?
space flight?
Yes, orbital. Okay, at least one time around the Earth. And we'll have some follow-ups about those kinds of things, but I was surprised. That's my hint for you, is that the answer surprised me.
The ISS has a really interesting orbit because
Let's save that. Save that for the trivia answer, because that connects to part 2 of the trivia.
Okay.
Oh, sneaky.
Okay.
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 All right. Let's talk about supernova.
They?
Yeah.
Supernova.
Supernovae may have been the reason for 2 of the mass extinctions that happened on Earth.
What?
Yes. Crazy, right? So
Tell me more.
it was using Gaia data.
You don't have to sing it.
Okay. So there was a team
It'd be real good
that
to us, though.
looked at over 24,000
I
stars.
just have to say I couldn't even tell that you were trying to sing it.
Wow.
There was like a pattern to it. There was a pattern.
You have taken some pretty nasty jabs at me
That's
before.
very true.
And so this is my opportunity to jab back.
All right. Yeah, that's fair. Okay, I'm not going to sing, but even if I were going to, you wouldn't know. So the team looked at Gaia data and took in over 24,000 stars, and they were doing essentially a survey of the most luminous stars within a certain radius of
Us.
Earth. Yeah, of us. And after doing this survey, they then looked at the rate of supernova events, and in particular, the rate of supernova events within a smaller radius, within about 60 light years of Earth, and found a rate of about 2 to 2.5 every billion years.
Okay.
And the reason why this radius of about 60 light years is important is because a supernova event happening within about 60 light years of us could be energetic enough to basically strip the ozone layer on the Earth.
Really?
Yes.
Okay.
They're
Interesting. Surprising.
supernova that are further away could also do it, but they limited it to about 60 light years from Earth as being the kind of key radius.
Yeah, they said within like 20 parsecs or something.
So
Yeah.
this is coming.
Catastrophic.
This is
Yeah.
coming from high energy photons from the supernova event that is destroying ozone. That's breaking apart ozone, or is it from particles?
Cosmic ray is what it said in the article.
Okay, so which are primarily protons. Okay.
Although, they did talk about iron 60. I'm not totally sure how that
I think that's just
fits
the
in with the
tracer.
story.
I think
Oh,
the
okay.
iron 60 is like something that tells you there was we got some stuff from a supernova.
Okay.
Yeah.
Oh, well,
landed
then that
on
makes
us,
sense.
right? Because that's an isotope that would be created in the supernova.
Oh,
So yeah, everything heavier than regular iron, everything more massive in the periodic table than iron, is made in one of these stellar catastrophes like a supernova or neutron star mergers or all
Sure.
these exotic high energy events, because the binding energy per nucleon has its minimum at iron, and then after that those things don't want to fuse inside a star. So everything heavier, all the heavier elements than iron are made in supernovas or neutron star mergers or these incredible astrophysics cataclysms. So I think it gives you a new appreciation for your jewelry. I see you've got some gold on you, festooned with
bling,
gold.
you know.
Addie,
Price of gold is at a record high.
Is it?
Ooh, I'm rich. All this gold.
All that. So that gold was made in some
Star.
event, like an explosion of a star.
Then why would a specific layer of iron 60 on the
So
Earth
iron 60.
as opposed to a layer of a whole bunch of heavy elements?
Things are made in different proportions.
Yeah,
Oh, okay.
that I
You look for iron 6. Well, I don't know. We can look at what they did.
I don't know in detail.
Okay.
I mean, I don't know if that's radioactive and it's got a certain.
It is radioactive.
Right.
Okay.
It's just used as a tracer. It doesn't mean the other stuff isn't there.
Isn't right.
Okay, cool. Well, this iron 60 was found in layers in Antarctic ice and in Apollo samples as well. So the study was done by these stellar astronomers, not by geologists. So I don't know if the layers in the Antarctic ice are correlated to these mass extinction events, but I think that they are. Anyway, this rate of 2 to 2.5 supernova every billion years happening within this 60 light year distance of Earth corresponds very nicely to the mass extinction event that happened 445 million years ago during the Ordovician. And another one that happened 372 million years ago that happened during the Devonian. And in the
And there's
Ordovician,
previous papers from 2020 that sort of said, hey, these supernova might be triggers for these events, these mass extinction events. So the previous paper said hey, something within 20 parsecs might be the reason that it's stripping the ozone. And so this new studies are looking for those sources. This new study is
cool.
looking for
Yeah.
those sources.
I mean, there's unrelated to extinctions, but aluminum 26, I believe, is the short-lived radioactive isotope that is produced in supernovas that is believed to have provided some of the heating for some of the processes in the early stages of our solar system. So that, like, stars were blowing up that maybe even helped trigger the collapse of our system into forming the solar system. And that stuff doesn't last very long. I don't remember the number of years, but it's like less than 1 million years.
Yeah, it's very short.
And so we're definitely part of the galactic ecosystem.
Sure.
Yep.
That way. And we've talked about that. I think recently we were talking about like galactic tides and the interstellar interlopers you were bringing up from Proxima Centauri and all that stuff. Here's another example of so destroy
do we
the
need to
ozone.
worry about another star doing this in the near future? Going supernova and destroying our ozone and causing a mass extinction because it gets so cold?
Well, Betelgeuse, I think, is the one that we've been
Is
talking
it in
about.
20 parsecs?
It is. Oh, no, it's not. No, it's not. No, it's
good.
not. Sorry.
Oof. Whoa. Okay,
Sorry.
I think we're okay.
It's 600 light years away, which is about
That's probably far enough.
200 parsecs.
Okay. Well, that's good. I don't think we have to worry about that one.
Okay.
Oh, yeah.
Yeah, and that one we probably have, I mean, we're not going to see it.
Oh, phew.
Oh,
You and
People
I.
on Mars
yay.
in the future see it.
No.
future Martian peoples.
So is the mode of extinction, is the proposed mode of mass extinction that you get rid of the ozone and then ultraviolet radiation gives everybody cancer or something?
I don't know
This
about that
paper,
specific.
Like this new paper is just about like finding the stars and stuff like that.
Yeah, and
Okay.
the rate of supernova.
And it's just like these things are happening and they're happening frequently enough that
And it
they could be a
correlates-
contributing factor, and the timing correlates with
Yes.
with these two.
Yeah, so there's there's evidence that the final extinction event at the Devonian Carboniferous boundary might have coincided with a dramatic drop in stratospheric ozone, possibly due to a global temperature rise. And so there's been previous studies that have looked at like reasons for the ozone drop, and one of those is a nearby supernova explosion that could inflict damage by accelerating cosmic rays
Interesting.
that can deliver ionizing radiation for up to 100 kiloyear. So like you have pretty long, the supernova go on like happen,
That's so
but you're
long.
you're sort of exposed to those high energy cosmic rays for a while, and it destroys your ozone, I guess. It's not an instantaneous thing. We'd have a tiny bit of time.
Yeah. And not everything died.
Yeah.
Right. But also, I mean, like, I don't know, but I wouldn't expect that marine life would be.
I don't know which type of extinction the Devonian Carboniferous extinction was.
It was a lot. It said one was
one.
75% and the other was 85%. And in both geologic time periods, a lot of the life was in the oceans.
True.
Right.
The Devonian is often called Age of Fishes. So there were a lot of fishes. And I think, if you like warm up the earth, it's going to affect the sea creatures as well, even if it's not like the radiation necessarily.
This isn't a warming event, though, right?
But if you get rid of the ozone, I
Is
thought
that
that's
a-
sorry.
is that a-
I thought that's what you said.
So I think of ozone as a UV absorber,
So it
but
cooled.
not as a. Well, I mean, no, it's absorbing
Or I guess-
incoming solar UV.
If you don't have ozone, you have a lot of radiation.
You have more
Okay.
like. We would get really bad sunburns without the
Okay.
ozone, and I'm sure other worse things.
But the sunburn
like-
would be the worst.
But I don't
Yeah.
associate it with like climatic change, like causing climatic change. The ozone's in the stratosphere, and so it is affecting the solar energy balance. Yeah, we're definitely clearly outside my
I was
realm
going to
of
say,
expertise.
we have a
Addie's
lot.
about to say, Josh, you remind me of somebody 100 yards out to sea flailing, flailing his arms about overhead.
Where's my oar?
Like, hello, a little help, please. Yeah. Okay. Cool.
Yeah.
One of the interesting things about all of this, right, and part of the reason we're so far outside of our little
Comfort
pocket
zone
of expertise is like it is this one of these cool studies that's like the study itself was about finding these stars and how
Right.
close they
Right.
are, But it's like, oh, also we're going to tie that to this previous study that looked at like mass extinction events and
We
how
need to know
supernova might be relevant to that. And that supernova paper that said supernova triggers for end Devonian extinctions is like talking about this other research that's been done looking at the like decline in UV and how that could trigger extinction levels.
Very
Right.
cross-disciplinary.
Yes, you need biologists, you need geologists, you need
Paleontologists.
astrophysicists
Yeah.
and paleontologists and fossil experts. And guess what? We're none of those things.
Oops.
But we play one on the podcast.
Right. Did you have another update you wanted to provide?
I wanted to read some titles from some fun articles that were posted on the archive today.
We should mention that we're recording this on April 1st.
Yes, we're recording this on April 1st, which one of the most fun things, if you're a big nerd, on April 1st is that people with way too much time on their hands, which I was texting with my friend earlier, and I was like, I don't have time to write a regular paper, let alone a funny paper.
Right. So first we should just give a very brief
Yes.
identify of what the archive is.
So do these things where they make joke articles. So they have like real titles and real author affiliations and like several pages usually. And then they post them on this place called the archive, which is like where you can post preprints of articles. And sometimes we get our sources here for the things we talk about on the pod. And it's like arxiv.org, archive.org. And like astronomy, physics people use it, but there are some for other disciplines as well. But anyway, so this is where you can post articles that like are preprints before they're published or once they're published. So there are legitimate papers that are often on this site.
Right.
But on April 1st, you can look at some of the new papers that were published this day.
Drop them.
Okay. The Cosmic One-Eyed Smile, revealing the hidden face of Mike Wazowski.
Is that from Monsters, Inc.?
It is, yeah, that's the one guy from Monsters, Inc. That one was kind of fun. And it's like a 5-10 page paper.
Oh my gosh,
with like
it is.
plots and things like that.
Oh wow.
Maybe this is a real paper.
There's a Monte Carlo Markov chain simulation
there is,
in there.
But then there's also figure one, the standard Mike Wazowski picture, featuring his iconic green body used as the baseline template in our Wazowski configuration modeling.
Wow.
So like, I don't know, maybe this is a real paper.
I want to see
this
that.
one's a little hard to tell though.
Can I see the Monte Carlo Markov chain thingy? That's wild.
There's also a prior and anyway.
The priors and the posteriors.
There's another one called Cat Stereoseismology, survey-based analysis of per-mode oscillations suggest inner lives of cats are unknowable.
Oh.
Wow.
This
sort
one
of
has
like black holes.
Cat stereoseismology or astereocatsmology, I don't know, is an unexplored area of observational and theoretical research that proposes to use per-mode oscillations to study the much beloved but poorly understood species Felis catus. So they look at how cats purr. There's some great pictures of cats. There's a picture of the detector they use, which is a cat curled up with a hand on top of it.
The hand is the detector.
There's examples of 2 stretch modes, arched back and butt up.
I would call that downward dog.
This is arched back.
Yes.
And then downward dog, but for a cat, that's called butt up.
Okay.
At least in this picture. So there's some fun.
The arch is definitely, that is actually the yoga cat pose.
Cat for cat cow. Let's see.
There's an article called All About Cookies, the perfect compromise between softness and crispness.
Ooh, that's important.
So if you really want to know about the compromise between
That one
the
actually
softness
sounds
and-
like a real paper, though. I mean,
it
This
is a real
one-
paper. It's on archive.
That's
Yeah.
right. This one is called The Eras Tour, mapping the eras of Taylor Swift to the cosmological eras of the universe.
oh my goodness. I wish I had had the foresight to write
You
a
have a
rolling
year.
quartz.
You have a year.
I know, but this one would have coincided with their North American tour, which has just kicked off.
It could, yeah.
And that would have been amazing.
Let's see. I have one more.
Okay.
Astronomers getting less creative over time, and why this title isn't better.
That's awesome. That's awesome.
And it's in the journal Acta Prima Aprilia.
That's awesome.
There are
April
many
1st
more,
Act, Prima Aprilia. Yeah. That's
so
pretty
those
awesome.
are just from the astronomy part of the archive, but there are many, many more.
Okay. All right. So you remember your trivia. The Fram 2 mission, which we now know
Can
what
I
Fram 2
finish
is.
the
now.
cosmological one really quickly? I just scrolled down. Okay. So they
Is this the
actually
Eras
tie.
tour?
This is the Eras
Mapping
tour.
the Taylor Swift's Eras tour
Taylor
to
Swift
cosmological
debut
errors.
is the gut era.
Grand unification
Grand
theory.
unification theory. So the beginning. We need Jim on here. Fearless is the electroweak era. Speak Now is the era of nucleosynthesis. Red is cosmic dawn. 1989 is inflation.
Okay.
Reputation is the cosmic dark ages. Lover is the era of atoms. Folklore is the Planck era. Evermore is the particle era. And Midnights is the era of galaxies. And then the Tortured Poets department is in the era of reionization.
Interesting.
Yeah, wow.
I have no read for how much of our listener base
Overlaps
are Swifties.
with Swift. I mean, statistically speaking,
Let us know.
many.
For all those,
Let us know
For all those
in the
eras, I recognized far more of the cosmological eras than
I should
the
hope
Taylor
you
Swift
recognize all the
eras.
cosmological eras.
I know there was one or two that maybe went by that I didn't. What were they?
I don't know, all of the main ones.
Yeah. All the main ones.
Burn.
They
Okay.
were only up to the reionization, though, which is like all very early in the
universe.
time of the universe.
Right.
So.
But pretty much nothing's
Taylor's
been
got
happening.
a lot more
The universe has been a pretty boring place since then.
until Taylor Swift came along.
Yeah. Thank goodness.
The Fram 2 mission, nominal inclination 90 degrees, meaning perpendicular to the Earth's equator.
Yep.
Right? Truly polar orbit. Prior to that, what has been the highest inclination human space flight?
I have genuinely no idea.
So pick a human space flight
Pick
that you have heard of.
pick a number between 0 and 90 for the angle.
I think I'm going to go with 30
Okay.
because that seems kind of high, but not like crazy high.
Okay.
There's also, I'm
I don't.
just going to,
I think it's going to be a mirror thing.
I know you want me to name a mission. I don't know of any that are just like orbital flights.
Well, I'm already,
You don't know
I'm
of,
already
like,
ready to tease you
Apollo,
mercilessly
Gemini.
just with your guess
Does
of
Apollo
30
count?
degrees. Yes.
All right, Apollo.
Apollo what?
Some of the Apollos orbited.
They,
Do an
3.
early number.
they all at least went around the Earth once.
3.
Apollo 3 didn't exist, but that's fine.
You told me to pick a number.
Addie told you to pick a number.
I did.
I told you to pick a mission.
Well, that's what I'm going with.
Apollo 3 at 30
If I pick another
degrees.
number, it doesn't matter if it's real or not. It's probably going to be
mission-
wrong.
A non-existent mission with an impossible
Oh, man,
inclination
this-
from
Yeah.
This
Canaveral.
trivia has gone awry.
All right, Addie. I'm expecting a more accurate.
I don't know which mission, though, is my
I
problem.
know. No, that's okay. Yeah.
I'm going to go one of the early Soyuz
Okay.
missions.
Okay.
Do I have to pick a number? don't
I would
know
like
what
you to
their
pick a number.
numbers
I will
were.
tell you to boost yourself a little bit there. Early Soviet is correct era. That is the
Oh,
correct
I'm in the
era.
right era.
Yeah. Not in the ionization era or
No.
the tortured poets era.
Um,
In the early Soviet space program
I'm gonna
era.
go early Soviet. So like there was Apollo Soyuz.
That's late Soviet.
It's late, so it was before that.
Oh, pick a number now.
7.
7 degrees?
No, oh, you said pick a number. I just
meant
picked a
the
number.
inclination.
The inclination, I think, is going to be like 67.
67 degrees. Okay. You did really well. So.
Well, you
now
had
we
to
have
do better than me.
Yes, you had to do better than Audrey,
Okay.
who picked
I'm excited to know
an
what it is.
inclination that is smaller than our latitude here at the launch site. And of course, it's really difficult to put. You have to make a turn
What's our
after you
latitude in
launch.
Florida?
I don't know what it is.
Well, here we're at like 31 degrees or something. I think here,
Yeah.
right? So it was close.
That's close.
30. I'll give you a soft pass on that. But if you launch from, say, a latitude of 31 degrees, and you draw a circle that goes through that, and that circle includes the center of the Earth, the inclination of that is going to be 31 degrees or bigger,
Oh, didn't think about that.
right? Because if it's less than that, it
pressure
never
hand.
gets
Yeah,
as
that's
far
what it
north
was.
as 31 degrees, right? So you would have to launch there, and then you have to do something. I mean, you could do it. Obviously, we launch things that go on to equatorial
very
orbits,
shortly be
but you have
30.
to make a
Okay.
trajectory
Okay.
correction. The actual answer, very close to Addie's guess, was 65.1
That's
degrees.
so close.
June 1963.
Okay.
Vostok 6, the sixth
6.
human spaceflight with
Couldn't remember
people.
what those early ones were called.
And the
Yeah, me
first,
neither.
this one was the one with the first woman in space.
Oh, Valentina Tereshkova.
Tereshkova, exactly right. Extra points for that. Just a fraction of a degree higher than the earlier Vostoks, which were all at about 64.9, 65 degrees. So they're all basically around 65 degrees. Now, the interesting thing to me and why this surprised me was that they all launched from Baikonur, right?
Yeah.
What's the latitude of Baikonur?
I was almost about to look that up. It's a good thing I didn't.
Yeah.
I closed the tab.
I thought the latitude of Baikonur was equal to the inclination of the International Space Station's orbit, because the International Space Station orbits at about,
No idea.
anyone?
No clue.
51,
It's like 40, 50. Okay.
51.6 degrees.
Okay, I knew it was right.
And we have always heard, it's at that high inclination orbit because launches from Baikonur need to get to it. So I assumed that Baikonur was at a latitude of 51.6 degrees. But Baikonur is actually at 45.6 degrees. Do you know why that we go to an even higher inclination?
I definitely don't.
Audrey knows none of
We
this.
have to be up there and down. Like, we have to have the right passes over.
No.
Oh.
No, it has to do with, think about where Baikonur is on its continent compared to where we are on our continent.
It's not on a coast.
Right. What's it next to going east? A different
I was
country.
going to say other countries.
Yes,
Okay.
that's exactly right. Specifically China. And they don't want to have an accident and have their stuff land in China. So they fly further north so that it will safely avoid having any debris fall in your neighbor. Whereas for us, our debris falls in the Atlantic Ocean.
Yep.
Right.
Where it should go.
Go into the ocean.
So anyway, I thought that was interesting. A little bonus follow-up trivia.
Oh, yeah.
Inclination of the Apollo vehicles around the moon. So those vehicles carrying people went to the moon, orbit the moon. What was the inclination of their orbits relative to the moon's equator?
That's a great question that I don't know the answer to.
I obviously have no
I was
concept of an
completely
idea.
surprised by this.
37.
But then it turned, and then if I
They're like-
replayed things,
They're like up in the 30s for the. They're up in the no, they're not that high. 7.
12.
okay, you're both right, except it's really like 170.
Because they went the wrong way.
Right. They
yeah.
were going backwards around the moon. So technically the inclination is flipped all the
Flipped
way
over.
over
Yeah.
from the direction that the moon
That's fun.
Sneaky.
is rotating. Because when I first saw it, I was like, what? And, then I was like, that can't be right. And I looked
It's
up
April
other
Fool's
sources.
Day.
Right. I looked up other sources. It's like, no, it's for Apollo 11, it was like 1 degree just over the equator.
Okay.
But it
So
was,
it was
179 degrees.
179.
Yeah, going backwards
Fun.
around. Yeah.
Sneaky.
Okay,
Fun.
cool. Ready?
No, yes.
Yep.
While it may have felt like waiting for a Mars sample return, it was
Oh.
just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Montreal and around the world. I'm Addie Dove.
I'm Josh Caldwell.
And I'm Audrey Martin. We're the Astro Quark signing off until the next episode of Walkabout the Galaxy.
That was a terrible pronunciation of Montreal.
Montreal.
It was
That's
like
okay.
a mix of English and French.
You know,